The next Thursday theory episode on the classical mechanics is here, and today I will show you what I have learned about the angular momentum in the rotational motion. My name is Xenophilis, and today, like every Thursday, I post a video about a subject in physics that I have already learned in my journey into physics. If you are new to my channel and want to follow me in my journey into physics, whether you are a student or a professor or just a physics enthusiast, consider subscribing to our channel. Don't forget to also press the notification icon so you won't lose any future videos. If you haven't seen any of our previous episodes of the classical mechanics theory or exercises, go and check the links below in the description or in the YouTube card above. As I already mentioned, today's video is about the angular momentum of a rigid body in the rotational motion. We have discussed about momentum in linear and translational motion of an object, and now it's time to understand momentum in rotational motion. You can watch the videos on torque and moment of inertia in the links below in the description or in the YouTube card above, and they will be helpful to understand today's episode. In this episode we will see the definition of angular momentum of a point mass and of a rigid body, the relationship between angular momentum and the moment of inertia, the relationship between torque and angular momentum, and finally we will discuss the conservation of angular momentum principle. As you can see on the whiteboard, we have a point mass, the vector of distance of the mass from the reference frame, and also the vector of each velocity. In physics, angular momentum is the cross product of the particle's position vector relative to some origin and its vector of momentum. So, angular momentum equals to the cross product of the distance vector and its momentum. As you can see, angular momentum is a vector product and has a magnitude, the product of the point vector mass and the magnitude of the distance and velocity vectors and the sinus of the angle of the two vectors. We can see the angle here between those two vectors. The direction of the angular momentum can be found by the right hand rule, just like we did in the previous episode on torque. A system of point masses consists of several point masses, so the angular momentum of the system is the sum of the separate angular momentums of each point mass. In a rigid body, like we have here on the whiteboard, we use integration since it is a continuous system of point masses. Now, let's find the relationship between the angular momentum and the moment of inertia on a rigid body. Now let's find the relationship between the angular momentum and the moment of inertia. We said that the angular momentum of a rigid body is the sum of the angular momentums. So, but we also know the definition of momentum, so We also know that the velocity of the equals to the product of angular velocity and the radius. So we have the following equation. This quantity here is the moment of inertia as we've seen in the previous episode. So, finally, the angular momentum of a rigid body is the moment of inertia of this body multiplied by the angular velocity of the body. Now, as in linear momentum, also in angular momentum, the quantity is preserved. So, let us take the rate of change of angular momentum in relation to time. We will use the differentiation on the angular momentum. And as we can see, this quantity here is the sum of the forces from Newton's second law of motion. So, we have that the rate of change of angular momentum in relation to time equals to the cross product of the total forces and the distance vector, which is, as we've seen from the previous episode, the total net torque. So, we've seen that the rate of change of angular momentum in relation to time equals to the net external torque. Now, if we say that the total external torque equals to 0, also the rate of change of angular momentum in relation to time is also 0. That means that the angular momentum remains constant. And this is the law of angular momentum conservation principle. If you like this episode, consider subscribing to my channel. You can also thumbs up and share this video. I would love to see your comments on this video to let me know whether you learned something like I did, and whether you found this video helpful. Follow us also on Facebook and Twitter and Google Plus for more content every week. Thank you for watching, and see you in another episode of A Journey into Physics.